A ball is launched at 25 meters per second at a 35-degree angle on level ground. What was the horizontal range of the shot? All right, just drawing the problem, we've got the initial velocity, just represented with a vector here, so 25 meters per second. Anytime you're given something at an angle, you want to break it down into its x and y components, the horizontal piece and the vertical piece. And that's just a matter of using a little bit of trig here. So the velocity in the y is 25 times sine of 35, right? Because sine has opposite hypotenuse, and this side is opposite of that angle. So you know you're going to run sine here, 14.3. And then for initial velocity in the y, you just use cosine instead. By the way, it makes sense that we would get a bigger number for this part, the 20.5, than for that part, right? Because it's a smaller angle. So this chunk should be bigger than that chunk, right? If it were bigger than 45, that would be the bigger one. So it makes sense that they fit this way. Once you've got that information, you just toss it in your y, x, t thing over here. The reason I put x at the end is because that's what we're looking for. We're fishing for delta x. And if that's the case, then we can't start with x. We got to use y to find time, and then that will lead us to x. So the problem kind of tends to flow toward the thing that you're looking for, but we got to find time in the middle. All right? So if initial velocity is 14.3, and every second it gets 9.8 slower, then we can find the amount of time that it takes to completely slow down and have a velocity of 0, right? Think about it. If you shot something up at 9.8 meters per second, 1 second later, it would have no velocity left. It would be at the peak. So what we're doing here is we're dividing. We're seeing how many times the number 9.8 can get subtracted from 14.3 before there's no velocity left to take. And when there's no velocity left to take, we're at the peak. All right? So the amount of time it took to get to the peak was 1.46 seconds, which means the total time that the shot stayed in the air, if this was at 1.46, well then it's symmetrical. So the amount of time you spent going up is the amount of time you spent going down, which means the total time is 2.92. We shuttle that answer over to the x direction where we can use it to solve the problem pretty quickly. The velocity in the x direction is 20.5, which doesn't change, right? Gravity doesn't pull left and right, it pulls down. Gravity has an influence on this side of the problem. Here it does not. That's why we split it up. We're looking for delta x, and you've known this equation since junior high probably, right? How far something goes is its velocity in that direction times time. And it's just a matter of tossing the numbers in. The velocity was 20.5, the time was 2.92, which means your shot managed to travel 60 meters before it hit the ground horizontally, which is a little more than half a football field. Not a bad shot. See you on the next problem.